Okay, so I'm going to run through the three transformations quickly that you are responsible for understanding, and I'm using the notes that we've provided you with parent functions. And so what I've got here is the f of x function. I've got the critical points or the characteristic points already filled in. I just used the graph that was here, and they gave me which points I wanted to use. I found the corresponding f of x value or the y values that went with those x values, and I filled in my chart. So again, just to make sure you're with me, the critical points are here, 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 and here, because it's where the graph changes. All right, so those are the 4 points that we used to fill out this chart. All right, let me get this out of the way real quickly so it's not a distraction. All right, now what we want to do is we've got to figure out what adding 4 to my function is going to do, and then try to come up with a name for what that is. All right, so what I'm going to do is I'm going to take all these f of x values up here, and I'm going to add 4 to each of them. So if I keep them all on the screen, it'll be easier to see. Okay, so when x is -1, the f of x value is 1. So what I'm going to do is 1 plus that 4 gives me 5. Okay, next, when x is 1 and f of x is -1, when I add 4 to it, I get 3. When x is 2, the f of x value is -1. I add 4 to it and I get 3. And then when x is 4 and the f of x value is -2, add 4 to it and I get 2. So now what I've created is a new set of points that I can use to graph an entire function. I'm going to use those as the 4 critical points. They're going to be like the skeleton of the function, and then I'll connect the dots to draw the rest of the points of the function so that we could see what it would look like. I'm going to do it in a different color, so I'll use red this time. I'm going to graph these points. So quickly, what I'll do is I'll go ahead and graph -1, 5. So that's left 1, up 5, 1, 2, 3, 4. Left 1, 1, 2, 3, 4, 5. It's right here. Okay, next one is 1, 3. So right 1, up 1, 2, 3. Okay, next is 2, 3. So right 2, up 3. And then finally, right 4, 1, 2, 3, 4, up 2. And you can see that it's actually the same exact graph. We've just slid it up or shifted it up 4 units. So the entire graph is the same, but we just moved it up 4. So what I need you guys to recognize is when I add 4 like this to all of the f of x values, I've affected the y values. I've affected the range of the function. So whenever we move up or down, that's a change in the y values. So when this +4 change happens outside of the x or outside of those parentheses, that means it's happening to the y values. So a change in the y values is going to be some sort of vertical change. So when I add 4, that means that I am moving up 4 units. So if I was to subtract, that would mean that I would be moving down. And again, if it's outside of the parentheses, that means it's affecting the y values. Anything that affected x's would be inside the parentheses. Okay, so now let's talk about if the change occurs inside of the parentheses. So this time I'm actually changing the x values. So that's going to be some sort of left and right change. All right, well, one of the things that we've discovered over time doing transformations is x's behave opposite. So even though this says x plus 4, and you might even get an inclination that I'm going to add 4 to every x value, meaning I'm going to move to the right because that's where I increase on the x-axis, I actually behave opposite of that. So I'll actually be subtracting 4 and moving to the left. So the way that we've got this table set up is that you should think about it in terms of what is x trying to do? It's trying to get back to f of x. So what would you do to x plus 4 if you were trying to get back to just x? Well, you would subtract 4. So I'm going to subtract 4 from each of these values. 1 minus 4 is -3. 2 minus 4 is -2. 4 minus 4 is 0. So now I'm going to graph the x and the y column to come up with my new graph, and we'll see what happened when we did f of x plus 4. So -5, left 5, 1, up 1. 1, 2, 3, 4, 5. Up 1 is going to be right here. Okay, -3, -1. Left 1, 2, 3, down 1. Okay, -2, -1. That's left 2, down 1. And then finally 0, -2. So don't go left or right, but then go down 2. And you should be able to see it's the same exact graph, but I shifted to the left 4 units, because x's, when they're getting affected inside, they behave opposite. So when I add 4 in here, I'm actually moving left 4 units because I behave opposite. This type of slide, where I was sliding up or sliding down, sliding left, sliding right, we call that a translation. And some of you guys already know that from Math 1. But that type of slide, the formal name for it is a translation. Now, how does this affect the domain and the range? Well, since I have affected the x values here, that means I'm affecting the domain. And since we moved left 4 units, all of the x values were decreased by 4. So I subtracted 4 from all my x values. So my domain, which used to be from -1 all the way to +4, now it goes from -5 to 0. So I subtracted 4 from every x value. Because I didn't affect the y values, the range stayed the same. So the range was exactly what it was before, from -2 all the way up to +1. Okay, now we're going to talk about the next transformation, which has to do with this negative out front of f of x right here. So what we need to make sure that we're paying attention to is the effect that it might have on either the domain or the range, and how that is going to affect our graph in general. All right, so if we just get our points off of the original graph, and then we're going to use those in our function. All right, so we got our points on here, and now we're going to go ahead and apply this change to the f of x values. So since this negative is occurring outside of the parentheses, that means it's affecting the y values. And so that means that we're going to have some sort of vertical change. All right, so what this negative is going to do, it's essentially telling us to do the opposite of whatever that value is, or multiply by a -1. Either way, we're going to change the sign. So instead of -1, it's now going to be +1. Instead of -1, it's +1. Instead of -2, it's +2. So now I'm going to graph the x and the y columns. -1, -1, left 1, down 1. 1, 1, right 1, up 1. 2, 1, right 2, up 1. And 4, 2, right 4, up 2. And now what you could see is it's the same lightning bolt graph, but this time it is a mirror image where the top and the bottoms flipped over the y-axis. So when I have this negative out front, that tells me I'm going to have a reflection. That's what that flip is. So I reflect over either the y-axis, the x-axis, or some designated diagonal line, y equals x through the origin. And this case, it's a reflection over the y-axis because I affected the y values, so I went from top to bottom, flipping over. Again, I want you to note that it's a reflection over the x-axis. Our final transformation that we're going to talk about is what happens when we multiply by a coefficient. So when we multiply, you can see that 4 is outside of the f of x, so that means it's affecting our y values. So what we're going to end up doing is taking these original values from our lightning bolt parent function, and we're going to multiply all the y values by 4. So that's going to make me have, instead of 1 times 4 is 4, negative 1 times 4 is negative 4, negative 1 times 4 is negative 4, and negative 2 times 4 is negative 8. So I'm going to graph those, and let's look and see what the effect is on the graph. Negative 1, positive 4, left 1, up 4, 1, 2, 3, 4. Positive 1, negative 4, right 1, down 4, 1, 2, 3, 4. Positive 2, down 4. And positive 4, down 8. 1, 2, 3, 4, 5, 6, 7, 8. And I connect the dots here of my critical points. And you can see it's still a lightning bolt, but this lightning bolt has been stretched vertically. So I still have the same domain, I still have the same x values, but I have been stretched vertically, so my y values have been affected. They've been all multiplied by 4. So we would say that this is a vertical, because that's the direction we went in, stretch times 4. And this number out front, that 4, is called the scale factor. So it tells you how much bigger or how much smaller your graph is going to get after you've been stretched. The opposite of a stretch would be a compression. So if I had some number, not a negative number because that's a reflection, but if I had some number smaller than 1, like 1/3 or 1/2, that would take this graph and shrink it down to where all the y values would be cut in half or cut into thirds. And so that would be a vertical compression or a vertical shrink, so to speak.